let's look at another example of solving a quadratic by substitution. So this time we're going to try and find values for p such that they hold true in this context. So we've got a quadratic and we can see two things in common, a p and a p plus 3, a p plus 3, but this one's the square root. So it'd be reasonable to assume that this portion here was, we could call an x, and this portion here would be the square of that, because that's a square root, and we could call that bit there x squared. So we've got an x and an x squared, so we could restate that now. So let's call that x squared minus 2 times x minus 3 is equal to 0. All right, let's go ahead now and factorize with a view to solving. So we've got factors of 3. So we've got factors of 3 is going to be 1 and 3. It's prime, nothing else. Signs are different. The biggest number is going to be negative, and of course we've got 1 and 3. 3 is the biggest. So there are factors. So we could say either x is going to equal 3 or x is going to equal negative 1. Now notice we've got a square root here. We don't really want to deal with the square root of numbers. Much easier actually to deal with a square of numbers. So rather than writing x is 3 and x is negative 1, why don't we say either x squared is 3 squared, and 3 squared would equal 9. Or we could say x squared is equal to negative 1, and negative 1 squared is going to be 1. But of course we now need to substitute this into p. So we've got, rather than stating an x squared, we're going to state p plus 3. So let's go ahead and do that now. So p plus 3, so that's our x squared. P plus 3 is going to equal to 9. Does that work out? Let's subtract 3 from both sides. And we've got p is equal to 6. So there's our first number there to test. Let's try the other one. So we've got p plus 3 is equal to 1. So if I subtract 3 from both sides, p is equal to negative 2. So there's our second number to test. So we'll do that over here. So I'm going to restate the question. I've got p plus 3, can you see that? You can, minus 2 times the square root of p plus 3 minus 3 equals 0. Is that true if we use p is equal to 6? So let's try p equals 6. I'll put p equals 6. And we're going to use that for here and for here. Let's see if that plays out. So I've got a 6 plus 3 minus 2 times square root of 6 plus 3 minus 3 equals 0. Is that true? 6 and 3 is 9 minus, or 6 and 3 is 9, and 2 times, we've got the square root of 9. Square root of 9 is 3. 2 times 3 is 6. Minus 3 equals 0. So I've got 9 minus 9 equals 0. It works. Therefore, we can say p equals 6 is a solution. That works fine. All right, let's try the other one. So I'm going to take p equals negative 2. Does that work as a solution? Well, let's restate the problem. So I've got p plus 3 minus 2 times root p plus 3 minus 3 is equal to 0. So I'm going to put the negative 2 in here and the negative 2 in here. Does that all work or not? Well, let's find that bit out. So I've got, what have I got here? P, so I've got negative 2 plus 3. Sorry, you can't see it. Negative 2 plus 3, I made p negative 2, minus 2 times, I got negative 2 plus 3 minus 3 is equal to 0. Well, negative 2 and 3 is going to be 1 minus, well, I've got negative 2 minus 3, it's going to equal 1. The square root of 1 is 1, so it's going to equal negative 2 minus 3 equals 0. So I've got effectively 1 minus 5 is equal to 0. Well, 1 minus 5 doesn't equal 0. 1 minus 5, in fact, is negative 4. And negative 4 simply does not equal 0. Therefore, p equals negative 2 is not a solution. But we do have a solution, and that is P equals 6 is, it's gone out of focus. Go back in focus. Good. P is a solution. Solution. And there is our result.